I'm here with Craig Arnzen from Area 419. We're going to tell you the complete story about the Area 419 Zero Press. Craig, thank you for joining me here at Ultimate Reloader.
Thanks for having me, Gavin.
Yeah, what I thought we could do is just tell the complete story from start to finish about the 419 press. I know you guys were hands-on with all sorts of equipment prior to even thinking about making a reloading press.
We've always been shooters. We love shooting. We got into it. John started spinning barrels in 2008 because shooting's expensive, so we wanted to offset costs.
You know what's funny? I just watched one of his barrel chambering videos.
Oh, those have a ton of views.
Oh yeah.
We still chamber a lot of, all of our manual stuff's the same way. We've got a lot of CNC in that process now. But it started with John was a shooter. Shooting's expensive. So he wanted to spin his own barrels to offset some of his costs.
Gotcha.
And from there, all of the products that we've manufactured and designed have been solving our problems or solving problems that we see on the range. And when it came to a press, we've loaded thousands and thousands and thousands of rounds on all of your common presses. I did most of my loading on a Redding T7 that my buddy Robin Sharpless at Redding sold to me. But there were things that I didn't like about it. And John loaded for a long time on a rock chucker, and we've loaded a lot of rounds on a coax. And they're all fine presses, and they're all presses that when they were released especially, they were miles ahead of their time, and each of them changed the game a little bit in their own way, but we were never completely happy with any of them individually. So we sat down and thought, okay, how do we make one that we're totally happy with? How do we go all the way on a press? And here we are with the Zero.
Yeah, and those products, it's interesting you talk about trade-offs. You know, let's take a press like the Forster coax. It has a really ingenious interchangeable quick change die system. It's got the universal shell holder. You can flip the plates and stuff like that, and you can load really, really great ammo on it.
You can.
It uses the principle of alignment on the top and self-alignment on the bottom, hence coaxial alignment from both sides. And then you mentioned the T7. Now, Redding presses, if you look at my 14 press reloading shootout, are great because they hold really tight tolerances and they perform really well. The T7 gives you the ability to leave your dies set up. And one thing I've noticed that I didn't talk about a whole lot in that shootout is the ram to press frame fit is very tight on both the T7 and on their single stage presses. And that's how they maintain that kind of alignment, those kind of tolerances. Well, there's also some friction there.
And with that T7 press that I've got so many rounds on, I know there was always there was some give and some take between how tight did I want the system to be and how easy did I want it to move. And that was one of the inspirations behind there being so many bearings built into a system that allows us to be without slop and without that friction. You know, how do we get the best of both worlds? In many things, you'll find there are no solutions, there are only compromises. You know, that's kind of the trade-off world in product design.
Yeah. And no one can patent everything, right?
Right, unless you really move in somewhere new and think, let's reimagine the way this process is done. So instead of trading off slop for friction, how about we introduce some components like bearings in the linkage to help us overcome that? How do we set preload? So any good product designer will tell you that parts that you can find off the shelf, you should use. These shoulder bolts in a lot of our original presses and a lot of our test units were off the shelf. But we couldn't get the tolerance we needed because the depth of that shoulder determines how much preload you have on those bearings. And in a world where 5 thousandths of preload makes a huge difference, we thought, we're just going to make them ourselves so that we can get a plus-minus number that's significantly tighter than anything we can buy off the shelf. And that was the kind of thought process that led us to, we like the T7, but we don't like the way the head moves. We really like a rock chucker, but we don't like having to change the dies in and out. We like the coax, but think that the idea that you're going to have your float indicate off a lock ring leaves a lot for us. Each of the presses do really cool things. You can make really fine ammo on each of the presses. But what we wanted was a press that allowed us to load in January and in July and in December, and every one of those lots be the same. And that was the big inspiration, and they all be of as high accuracy potential as you could possibly be. That was the inspiration behind the Zero, and the Zero is the beginning of, and we'll talk about it more at length later, what we think can be something really forward-facing in the reloading community, because most of the reloading technology that we use, especially on the press and die side, is older than either one of us, and really both of us put together. And we're ready to re-examine it, and it's a risk for us, and it's kind of outside the box, and we love that.
So to wrap up sort of the existing product ecosystem for reloading presses, you've got 3 different types, right? You've got your single stage, which has 1 die station and 1 cartridge station. You've got your turret, which has multiple die stations and 1 cartridge station. And then you've got actually a lot of guys loading match ammo on progressive presses, like the Dillon 550B or C. And all of those systems have their trade-offs. Now, early when you guys were thinking about, producing your own reloading press, was it always going to be a turret, or did you think about a single stage or a progressive and that kind of thing?
We use all those things. I've got a Dillon 650 with a case feeder that I use to decap, because the fewer times I can touch a piece of brass, the better. And I like to clean brass before I put it in a nice die.
And you're shooting PRS mostly?
Yeah.
Is that fair to say? Okay.
Yeah. PRS is where I compete. It's where I do my shooting significantly.
So 3rd MOA or less approximately would be.
If my gun's shooting in the 3s, I'm a happy guy.
Yeah.
But our bar here was talking to friends of mine like Lou Merdika and Jim Borden, both guys that have forgotten more about accuracy than I'll ever know. Guys I really respect, and guys that are both Benchrest Hall of Fame shooters. And with them, it was conversations about, I'm seeing variance here, why am I seeing it? Or I don't know why this is happening, or I'm struggling with this. And the beauty of those guys is not only do they know what your problem is, but they can tell you 4 or 5 stories about all the different ways they've tried to solve it over the years. Or, Jim's still got Borden accuracy and is doing a great job there, but Lou is often at his reloading bench in the day and can take a photo of something that he's got that is the only one ever made that solved this problem, but then did this happen and this happened. And the things that have happened with component technology and reloading technology, the brass today is so much better than it's ever been. The bullets today are so much better than they've ever been. So what we're capable of on the bench is so far in excess of what we ever have been. We wanted to build a press that would allow you to take advantage of those things over the long haul.
Yeah, if you're like me, there's what you need to get a job done, and then there's going to the extent to see just how good you can do, right? And when you go to that level, then you do bring in not only the PRS crowd, for instance, but folks like Benchrest shooters.
Yeah, a lot of these presses, we've sold, by the time this airs, we sold about 500 of them. And many of them have gone international to the mature F-Class and BR communities around the world, and have gone to a lot of guys that weren't necessarily customers of ours before, because we've been PRS focused. It's what we do. It's what we love. But we know that the high precision community is very interested in this. And we all shoot and load because we love it at the end of the day. We love, if we're loading hunting ammo, we want to go take that harvest. If we're loading competition ammo, we compete because we love it. We don't load because we have to compete. It's all based on love. So if we can produce the best end product possible in that ammo, and there are certain creature comforts built into the press that if you can enjoy that time a little bit more, it's a win-win for us, and we're really proud of the Zero.
Yep, okay. So that pretty much covers what was available at the time the Area 419 was conceived. Next, let's talk about the whole process of coming up with this design, testing it, and verifying it. So I can recall hearing about the Zero Press, I think it was last spring.
We made the first announcements about this during the quarantine, so it all kind of lined out nicely. We hit 100,000 people in a day with that initial launch, so it was great. Everybody was sitting at home, looking for something to do, tired of their family, whatever they were doing at 1 o'clock on a Tuesday in April. And the Zero kind of exploded from there. It was something that was an initial concept that went into, like many of the products do, John draws up the first one in CAD, and then says, Craig, come in here, look at it, tell me what you don't like.
Without a sketch on the back of a napkin or anything like that?
That's where he sketches.
Okay.
Gotcha. That's the way that John's mind works. He loves working in CAD, and that's where, if we're working on any project and he's trying to explain how he thinks, I just see it on a screen, because that's how he likes to draw. Very rarely will something be sketched out on a notepad. I draw that way, he draws on a computer. But he calls me in, and it's basically the rough outline of the press, and he says, all right, what do you think? And I said, well, let's pick it apart until we hate it and fix it and keep going. And that's how a lot of product development has gone over time.
Interesting. And so fast forward to today, here we are in November 2020. I mean, it's only been like 6 months.
We went from that launch in April to taking orders in June, or in July, sorry, right after 4th of July, like the 7th, and shipping that first batch in early October. We thought we'd be able to ship in September. with the gun world going bananas, nitride, nanodice, things like that got very slow.
Yeah.
And we actually ended up waiting on our foam, which is very nice foam, and we like it. But again, everything in Corona world is a little bit slower to get a hold of.
Oh, yes.
So it worked really quickly, and it was a product of things that we liked or didn't like, things that people, our development process was very open air. When we first showed this thing off, it was renders, and we had some parts that we'd played with, and there was some certain proof of concept stuff we were doing. But a lot of it was, we're gonna make this development public, and there are, like, one of the big changes is originally the linkage was down here lower on the nose because that did some different things in the physics of a 4-bar linkage that we liked, but we didn't like what it meant from a material stability standpoint. So this moves, and some of the shape moved, and a little bit of the way the primer system changed, and the turret head, for example, the very first one that we made was all out of softer 6061. These are 7075 now. It was softer 6061, and the pull stud was just a carriage bolt. And we knew that that was obviously not going to be strong enough, but we didn't want to overbuild and then start stress testing because then you don't get as clear of a picture.
Sure.
So we wanted to be able to see things more simply, see things more easily, and then build to the point of it working, and then keep building, but know where we're looking and what might fail and what might not work. And the bearing package, specifically the linear bearing, was a long project because we've got a lot of movement. There's a lot of moment here when you start. Your forces are very off angle. So how tight can we make that bearing? Because the tighter clearance gives you less movement up top and still get free range of motion. How do we make that bearing work to where you don't get a little bit of a stick when you start? All of these things, there was a lot of work in progress. And there were a lot of things that we did that then were undone because we didn't like them. But it was a process that led us to what we think is the finest press you can buy.
So tell me the sort of sequence that evolved to get from these CAD sketches to the very first press that you prototyped on the CNC machines.
Well, what's wonderful is we're a small business. So
and in-house too, right?
It's all in-house.
No COVID, my outsourced machine shop can't deliver.
The
blah,
only
blah, blah.
things on here that are outsourced were like set screws and snap rings, and then obviously coatings. We don't anodize, we don't nitride. So there are 22 unique in-house made parts on this. We don't make bearings, but really everything else we either made or modified from stock. But when we made the first one, it was John walking out in the shop, which we're still in John's backyard, on a weekend, and coming back in the next day, and we've got a turret and 2 arms and some parts, and we just kind of went for it. And immediately found things we didn't like, and every new iteration. One of the initial videos where I talk about the press, I'm sitting in the corner of our reloading room, and you've got the window in front of me, and there's a whole line of in the white aluminum press bodies, and that was probably 8 of the 15 or so that were just trash over time because we'd make one, and this didn't work, or we didn't like this, and we changed 2 or 3 things at a time. And that's the nature of the process for us. It's rapid prototype. We're making live samples. We're using them and abusing them. And we make new products. We made new revs to test and alter little things over time, and we got here.
So what was the hardest thing, would you say? I mean, the pull stud and the clamp seems to be one of the things. All of the bearings and the geometry of the linkage is another thing. This press does some things that are a little bit off the script, if you will.
So there was the hardest to figure out, and then there is the hardest to execute.
Let's talk about the hardest to figure out first.
The hardest to figure out was actually this linear sleeve bearing package and the relationship between length of the bearing, lubricity of the inner material with the PTFE lining.
Because it is self-lubricating, correct?
It is. It's PTFE, or a trade name for that would be Teflon lined inner bearing. So it's very slippery, it's very slick. It's also reasonably hard, so it's going to not wear outrageously over time. Plain Bearing Company, PBC, the company that we get those bearings from, and then we alter them. They say we should be good for 10 million strokes before we see 1,000th of erosion, so we're going to be fine there.
If you're loading more than 10 million rounds of ammo,
call us, we'll send you a new bearing.
Right.
You got to prove you loaded 10 million.
Right.
So figuring out exactly what that length needed to be, and us being a small shop, we're not going to order 10,000 of these bearings at a time. It's how do we take that off-the-shelf part from PBC and turn it into something that can work. So it was turning it down to an OD that we liked. We actually parted it so that we could create more space and create a kind of a trash vent in there because inside your decapping chute, you can get little bits of dust. So when you get to the bottom of the stroke and it hits and you get shake, that doesn't live in your bearing, that goes away, that vents out. So exactly how that system wanted to work and how long things needed to be, exactly the OD of the shaft, that is Thompson shafting, and anybody in the manufacturing world will recognize that that's really high-end bearing grade shafting. The outside diameter repeatability on those is to about the 10,000th.
Wow.
They're super, super repeatable rams. So yeah, exactly how that package on the linear bearing that guides the ram wanted to work. That was the hardest to figure out. The hardest.
And this solves the problem I was talking about with the Redding press, right? Where you've got a really good fit, but you've got a lot of friction because you've essentially got a ground rod inside a cast iron
Where
casting,
most of their
right?
friction comes from is actually in the linkage system, because you've got metal on metal that if you're not constantly oiling and greasing, metal on metal over time is a bad thing.
Yep.
So you have to choose between, do I want the system to be tight, at which point it's all held together,
Right.
or do I want it to have room to move, at which point it all can become a little bit sloppy? And that's the nature of just a metal on metal assembly.
Yep.
And even though cast iron is a naturally self-lubricating item, it's not a bearing. You know, you're not
Right.
working on balls.
And it's dissimilar, right, with respect to the ram itself. So the grain structure.
But that can be
should
okay. You know, most of their issue doesn't come from the ram unless you get contaminants on the ram. Most of what you're feeling is actually in the linkage system and choosing between having it tight and having it loose for movement.
Right.
So that's where you're going to find most of their
ball bearings and linear bearings and all of that help to solve that problem, right? Where you have the precision and you have lack of friction.
You can have tight things still move when you're moving on things like balls. And that allowed that system to, when you pull the handle down and move side to side, your mount's going to torque and flex before the system torques and flexes.
And then you've got the thrust bearings also, which can keep these side plates tight.
Yeah, it allows us to stay tight and still allow those ball bearings to move around one another.
Okay, so that was the most difficult thing to figure out. What was the most difficult part for execution?
The most difficult part to execute is actually in here. So we wanted to control exactly how much space there was between the pull stud and the bushing inside the body of the press. So on each of these presses, your basic clearance between your OD here and your ID here is between 3 and 6 10,000ths. That's really small.
Yeah.
And that comes from, and what's difficult there is this pull stud is a very robust piece of steel. This is thick steel. You're around 1.25 inches there. And when you send it out to heat treat, it grows. When you send it out to nitride, it grows. So keeping those products on size and perfectly round was the most difficult, because when you're talking about a clearance of effectively a 0.5 thousandth, that's no space.
Right.
I mean, you're teetering on the edge of it being a press fit, and you obviously don't want that because the product has to be able to move. So producing turrets and bodies, and there's a bushing in here that is nitrided steel. That's a Rockwell. Everything's Rockwell of above 60 in this wedge and pull stud and bushing unit. Keeping those on size and working together and hitting those clearance and tolerance numbers was definitely the most difficult thing to execute here.
Is that a QC challenge as you have the ongoing process of building these? I mean,
it's a manufacturing challenge first. QC is to catch mistakes. Manufacturing is to do it right. And finding ways to hone the manufacturing process to allow us to hit those numbers on a repeated basis, that was a real challenge. That's something that John and our team and Justin, our operations guy, they did really, really well in lining out. And there was some trial and error up front. We have several presses that can't be used because how do you get exactly to that right spot? And there are some things that you have to figure out the hard way. And we did, and that was part of the process, and it led us here. But that whole process of how do we hit clearance and tolerances in the critical locations with multi-process parts, because this pull stud is made out of A2 tool steel. It's turned to just a little oversized. It's sent out to heat treat. It's then hard turned down to on size and then sent out to nitride. And we know that there is actually going to be a little bit of change in material size when it goes through that process as well because of the heat. So knowing what's going to happen at each step and being able to build a system to it, that's the hardest to execute.
Yeah, and you can truly feel just how tight these tolerances are when you put the turret in place, I mean, you need to be pretty well aligned. Otherwise, you can get it to stick a little bit, obviously. And, you know, if it wasn't so exacting, the tolerances, it wouldn't be that precise.
It's a good thing that it's difficult. And the most gratifying part is when you're right here and you get that rotation, that it hits so perfectly. And there's not the play, there's not the wobble.
Yep.
And it allows you to take that turret out and put that turret back in and see effectively no change to anything going on in your brass. You're going to repeat within a half a thousandth.
Yep. Okay, so that was the process, the 6 to 9 months, whatever it was, from idea to product. Next, we're going to talk about the final product. So here we are. The Zero Press has been on the market for about a month now. It's a real product in real packaging. Tell me how people have responded to the Zero so far.
The best way to answer that is that the second batch will be sold out before they're ready to ship. This was a product that saw really strong reception before anybody had ever seen it or touched it. I think we hit on something conceptually that was very strong with people. And what we knew and what we were excited about is we were going to ship these products. And the common feedback that we get is, especially friends that bought one, that maybe they're supporting 419 because they like us, but really weren't sure what they were going to get into with the press. They opened the box and said, Craig, I thought it was going to be cool. I'd seen the videos, I'd seen photos, but I couldn't imagine what was going to come out of that box. And it's so much more of a unit and a machine, and the feel and the experience. You can't convey it in photo, you can't convey it in video. We're going to try the best we can, but the machine over-delivers on what we think are pretty strong promises.
Well, you heard my reaction. I specifically did not open the box until the cameras were rolling.
Right.
And I was actually kind of laughing, like, this is not a press, this is an experience, you know?
It is. It is. It's bigger and smoother.
Yeah.
It's delivering something that isn't expected because it doesn't exist anywhere else. And I think that's what guys are finding out when they open the box, and then when they get it on their bench and they call their buddy to come over and their buddy puts hands on it, he wasn't expecting it either. So there's another one that's out the door. These are all over the world now, and we are consequently getting more dealer requests and things like that from all over the world. So it's a major international growth opportunity for us as a brand, and it's one that has left a lot of happy customers, return customers, as well as we have a lot of customers that the very first thing they ever bought from us is the press. And we think that those are going to be loyal customers for a very long time because of what this press is able to deliver.
Yeah, and you know, it looks cool. The packaging is awesome, but also in terms of functionality, it delivers some things that are pretty interesting, I think. Like the Turbine CNC Press, right? Linear bearings, totally locked down accuracy. It uses some of the same principles around things should be aligned and not have to self-align. Right. Price point pretty similar. This press allows you to have some of those same benefits, but to not disrupt your dies and to not have to handle your dies.
Yeah, that was one of our big complaints is the use of traditional dies. So 7/8-14 threads have been in use since the early 40s. RCBS has never not made 7/8-14 dies, neither has Redding. And it is, with that coarse thread and that class 2 fit, not terribly consistent. So if we can get rid of that inconsistency, let's go. If we can find all those little places to eke out just a little bit at a time, that can culminate into something that is different and is really better.
Like you and I were talking about one time, these competitors will go so far as to chuck up a die in their lathe, and then turn the rings down so that when the rings clamp together, you know, they sit a certain way, and they're going to turn that down so that it sits perfectly in the press. And that
I've got friends I've talked to in the BR and the F-class communities that'll buy a dozen shell holders at a time and put them in a lathe with indicators and figure out which one of those dozen they're going to keep because they want everything to be square. It's that level of, can we make it perfect, that we were striving for here. We think this press can create accurate ammo for anybody that buys it if you know what you're doing at the bench. But we think that for the guys that really, really know what's going on and are competing at the very highest level, where a tenth or a hundredth or a thousandth of an inch matters, we think we can offer to you a competitive advantage over time, consistency over time that nobody else can. I want that ammo, whether you're loading it in January or July or December, to be exactly the same as that last lot.
And what's interesting about that is you take what could have been a limiting factor in the reloading press, and then you start looking elsewhere, right?
Right.
Because what I love about precision rifle shooting and building precision rifle ammunition is everything has to be right. You know, the shooter has to be right, mindset has to be right, the weather has to be right, the rifle has to be right, ammunition has to be right. Any problems in any of those areas will cause you to be off target or to have larger groups.
Every variable
right?
is something that we want to get rid of, and that's part of the shell holder retention. You know, people look at the press and they say, "Well, I don't want a turret. I want a single stage. It's going to be more accurate." And it's kind of a single stage too. Or they say, "I want the turret to be faster or do some different things." Well, it's really something that I would describe as a single stage press with uber repeatable die storage, because it's going to give you that rigidity, that lockup that you're used to with a traditional single stage, but it's also going to give you that convenience factor from a turret without the limiting factor of turret heads being mobile, which leads into categorically slop and looseness. You've got to have that play in a traditional turret head. We've solved that, and we think that we're delivering truly the best of both worlds.
Let's talk about a couple other things on the press that we didn't talk about already in this particular video. We've got the spent primer tray. It's like a little drawer that goes in the side, and internally there's a passageway, right?
We dislike surgical hose and baby food jars and those things hanging off of presses. We built a beautiful press. There's no bones about it. You don't buy an ugly Ferrari. We wanted it to look good, and keeping that clean and tight was important. And that comes to, it's a 1/2-inch hole that comes down to the center of the press, and then turns, and it's drilled from both sides, and we can do that because we machine the entire body in one op on a 5th axis machine, so that when you decap at the top of the stroke, that primer drops in, drops down, and you can fit a lot of them in here. It's black because primer dust is disgusting.
True.
You can put a lot in, you can dump it out, you can go on with yourself, and aren't dealing with things hanging all over the bench, because we've all decapped with a surgical hose that runs to a 5-gallon bucket. We've all been there, but we didn't like that. It wasn't the experience that we wanted on the reloading bench. So the primer system's fun for us.
That's cool. We also have the roller knob.
It's John's favorite part of the press. He got in, and at one point he says, "Hey, come in my office," and he shows this to me, and he's like, "I know it's over the top and it's way over engineered, but it's my favorite part of the press." And truly, it gives you a feel and an ability to move the hand. A lot of people thought, I want a roller handle like an ergo handle from Inline for like a Dillon. The downside of that is you didn't have to have a bent arm, because that has to run on kind of a smooth plane. Knowing that we were going to have an angle out because our shoulders aren't narrow, and we want that connection to be close to the center of the ram. It was going to be running out on kind of an odd plane, so it needed to rotate. So let's bring to market a ball bearing handle of the sort.
Nice. And then there's also ambidextrous mounting for the handle with the pinch clamp, and you use the same key, right?
Yes, everything's quarter inch.
Yep.
Everything's quarter inch. There's also a hole here in the linkage block. We'll end up doing shorter handles.
Oh, cool.
So that if you have that longer handle and you want a shorter one on there at the same time, I just got a request from somebody, "Hey, can I get one of these in half the length?" No, we got a product, we're going to do something with that. But the same concept of being able to have both on the press at the same time, because not everybody can have a handle run underneath. That's something that we take seriously, because that's a very feel-based thing. How long is the handle? Where's everything going to sit?
Yep. And then we also have Arc-A-Lock.
We have Arc-A-Lock on the back.
The rail on the back, and you were telling me that at the factory you guys use this to lock the press in place so that you can kind of...
So the genesis of this is, it starts with, this is a big piece of American plate aluminum. It's really nice aluminum, but we got to have somewhere to grab it. So we put it in a vertical mill, and we run 2 sides down here and create a side panel. We use the Lang vise system in our 5th axis. So when the press is machined, it's held right here in the trunnion of the 5th axis. We machine everything on the body in one operation, and it just so happens that when we're done, that's just the right size to drop it back in a mill, finish out on Arc-A-Lock. And with that Arc-A-Lock, we can assemble. When we assemble them in the shop, they're hanging from an Arc-A-Lock clamp floating out in space, and we can rotate them. It's a 30-pound press. You don't want to be manhandling it on the bench as you
It's
as you
aluminum,
assemble.
but it's massive.
There's a lot of it. Yeah. If it were steel, it'd be a 100-pound piece.
Right.
And it gives us the ability to assemble. And we also have some forward-facing things Like the first thing that'll be out to market will be a storage tray. That's something that's probably a Q1 item just for manufacturing capacity reasons. It'll come out the side. You'll have a nice storage place for your torque key, a nice magnet for your calipers, shell holder storage, as well as a little tray because even though you don't, everybody else has just the tchotchkes on their bench that they're little tools or things they use over time. So a little storage hanging off the back, as well as some other things that'll be around in the future.
Nice. All right, that's a good transition and a segue to, let's talk about what you envision looking forward. You've already talked about hybrid turrets and then accessories. Tell me where things are going here.
We've got dies that by the time this airs will be either will have shipped or be shipping very soon. We've got turret heads that are hybrid 1 1/4 and 7/8, as well as turret heads that are all 1 1/4.
So those are alternating 7/8, 1 1/4, 7/8, 1 1/4.
The hybrid is 2, 2, 2, and 2.
Oh, take 2, 2.
Meaning the reason for that is some people have full die sets that are 1 1/4, and some people might only have, let's say, a Warner sizing die in 1 1/4, but they're still seating with a 7/8 Redding micrometer seating die. We want those to be next to one another. We want you to have that ability. Or if you're running 2 1 1/4 dies, those can be next to one another. So it gives you some good versatility. Our friend Shiraz at Grizzly was actually the phone call where we kind of ham and egg that thing for a while and figured out what we thought was the best solution. So those will be out.
So he has one of these, does he?
He does. Yes.
Nice.
Shiraz has one, and he's waiting on his hybrid turret head, so that'll be out to him soon. But the next step past that, we're going to make shell holders. We've already got our bullet seating plate, which is it's stainless steel, but it's ground on both sides. They can go in the shell holder area and give you a perfectly flat seating surface. So if you want to seat with a Redding die, kind of like it's or a standard seating die, kind of like it's a Wilson Arbor style, you've got something that pushes flat up, big surface, flatter surface. Based on the way that standard shell holders are made, it's very difficult to have a true flat surface. You can't grind them.
Right.
So providing that true flat surface is nice for seating. It also makes sure that your floating seating body, like you see here, doesn't contact the shell holder because you want it contacting the body and the shoulder of the case for the alignment feature that's inherent in these dies. If they're contacting the shell holder, you may have a floating case inside, so you're not getting that shoulder to neck to bullet alignment that these dies are built around.
Interesting.
And then there's 2021.
Yeah.
Right
around the corner.
Yeah, it's going to come here fast.
Yeah.
And hopefully it's better than 2020 for most of the world. But we're going to roll out shell holders, and we're going to roll out dies that will be systemic. There's some cool things that we're working on there. They'll work together. They'll work with the press. And we think we can bring some features and functionality to market with dies and shell holders that nobody else has seen.
Okay, I'm all ears on that. I'm really anticipating
You'll
what's going to come.
enjoy
Okay, well, I think that's a great sort of start to finish look at Area 419, the Zero Press, and of course, you've got a lot more that you're going to see here on Ultimate Reloader. So make sure you're subscribed with notifications. Also, what do you think of the Area 419 Zero Press? Do you have one? Do you want one? Do you have another press you like to use instead? Drop a comment and we'll start a discussion. Thank you, Craig, for coming by.
Thanks for having me.
I really appreciate it. We're going to be working on some more videos here while Craig's here in town, so make sure you catch those. Got Ultimate Reloader shirts at the Ultimate Reloader store. I'm on Patreon. Links down there in the video description. We'll also have a link to a full article with more cool pictures and stuff like that. Thank you for watching. Until next time, happy shooting and happy reloading.